Hello everyone, we are Group 106, consisting of Kartikeya, myself, Avinash, and Bharadwaj. Our project is titled DeepGuard, Fighting Online Hate with Neural Networks. Over the next few minutes, we'll show how we built our compared neural network models to detect hate speech with increasing complexity, starting with simple RNNs, moving to LSTMs, and finally using BERT. So the motivation behind this project is that social media has enabled open conversations, but also widespread hate speech. Traditional systems fail to understand the nuance in language like sarcasm, cultural references, or like coded hate. So we wanted to explore how deep learning, especially context-aware models like BERT, can help us more effectively, detect hate more effectively. So the main input and output segment which we use is the task is simple, quite simple. A user submits a social media comment and our model predicts whether it's hate speech or not. Behind this, though, are that have been trained to understand language patterns, emotional cues, and implicit bias. The main methodology which we used is we use the ethos dataset containing social media comments labeled for hate speech. For pre-processing, we tokenized and padded inputs for RNNs and LSTM models. And for BERT, we used a pre-trained tokenizer from TensorFlow Hub. Evaluation was done using accuracy, precision, recall, F1 score, and confusion matrices, giving us both overall and class-specific insights. The baseline model for the simple RNN was our first model. It was a simple RNN with two stacked layers, each with 128 units using 50-dimensional word embeddings. It was trained on 15 token sequences, while the training accuracy was high. Test performance were poor due to overfitting and limited memory. It just couldn't capture long-range dependencies in language. And for the LSTM model, to address this, we moved to an LSTM model where the LSTMs can retain longer-term context. So we increase sequence length to 150 tokens and stack two LSTM layers. We also added dropout to prevent overfitting. This model shows major improvements, especially in F1 score, and meaning it could like the meaning is we could detect hate more reliably across varied sequence structures. And for the fine-tuned BERT model, we implemented this by the BERT already understands language from pre-training on a massive corpus. We just added a few dense layers on top and fine-tuned it on our hate speech dataset. It requires minimal pre-processing and performed the best across all metrics. It could even detect subtle hate and sarcasm better than RNN or LSTM. For optimization, we use early stopping and dropout in the RNN and LSTM models. For BERT, we fine-tune with a small learning rate and smaller batch size. We also tune the input length carefully, 15 tokens for RNNs and 150 for LSTMs. While BERT uses default 512 token max length for full context capture. And here's the performance summary of the three used models, the simple RNN, LSTM, and BERT. As we can see, the simple RNN has accuracy of 56% and an F1 score of 0.18. It is not suitable for real-world use. LSTM has an accuracy of 72% and BERT has an accuracy of 78%. LSTM has an F1 score of 0.65 and BERT has an F1 score of 0.76. Simple RNN is not suitable for real-world use, while the LSTM is much more stable and usable. And BERT is the best overall performer. BERT's strength lies in its contextual understanding, making it ideal for real-world applications. As a team, we had prior experience in NLP projects like sentiment analysis using Naive and BERT. Some of us also experimented using optimization algorithms like Ant Colony and Adagrad in earlier work, which helped us fine-tune our models more effectively. And these are some of the references that guided our model selection and evaluation strengths.
Project. So here we can see all the imports and the EDA part as well as the model training part. This is the EDA. This is the first RNN model. This is the LSTM model. And this is the BERT model that we trained. And next application.py, this is the front end web application that we have built. So this is a small index. This is the interface part. So let's just test the front end of the model. So if we give a comment here and run the mod and press run, we will get whether this comment is hate speech or not a hate speech. Let us try with your idiotic and pointless, which is obviously a hate speech. And when we run that, we get the result as hate speech with a probability of 94.3%. Now let's comment something which is not hate speech. Let's try peace and love. We can see that the result is not a hate speech with a probability of 100%. Thank you.